Evaluate the following double integral over the region R. And we have the double integral of 2 times the square root of x by y dA, and R is the region in R2 where x is between 0 and 1, and y is between 9 and 16. So notice, because we have a rectangular region here, we can use either order. So when we start here and we set this up, we want to keep in mind we can go one of two ways. We can rewrite this as the integral from 0 to 1, the integral from 9 to 16 of 2 times the square root of x by y. And then notice, because we have the y bounds on the inner integral, the order will be dy dx. And equivalently, we could also evaluate the integral from 9 to 16, the integral from 0 to 1, same integrand, 2 times the square root of x by y. And here this order would be dx dy. So no matter which way we pick, we'll get the correct answer. So I challenge you to try both ways. So I'm going to go with the second case here. We'll do dx dy. So the first thing I want to notice is my inner integral. So that's where we'll start. So we're going to begin by evaluating the inner integral here. So we have the integral from 0 to 1 of 2. And I'm going to separate this out. So I have the square root of x divided by the square root of y dx. And I can pull the constants to the outside of the integral. So I have 2 by the square root of y times the integral from 0 to 1 of x to the 1/2 dx. And so we integrate this. We have 2 by the square root of y multiplied by x raised to the 3/2 divided by 3/2 or multiplied by the reciprocal, 2/3. And we're ready to evaluate from 0 to 1. And so this becomes, so I have 4 over 3 times the square root of y multiplied by 1 to the 3/2 minus 0 to the 3/2, which leaves us with 4 by 3 times the square root of y multiplied by 1 minus 0, or just 4 divided by 3 times the square root of y. So now we can take this and we'll substitute it back into the double integral to finish by evaluating the outer integral. So plugging this back in, and then pull my constants to the outside here. This is 4/3 times the integral from 9 to 16 of y to the negative 1/2 dy. And we're ready to integrate, so that's 4/3 multiplied by y to the 1/2 divided by 1/2, so we'll multiply by the reciprocal, 2 over 1. And now we can evaluate from 9 to 16. So this is going to be equal to, and again, actually, we might want to rewrite this one more time for good luck. I have 8 by 3 times the square root of y from 9 to 16. So this will be 8/3 multiplied by the square root of 16 minus the square root of 9. So I have 8/3 multiplied by 4 minus 3, which gives us 1. So we have 8/3 times 1, which leaves us with a beautiful final answer of 8/3.